Today we're going to be doing some problem solving using tangents and chords within a circle. Let's start by reminding ourselves of a couple of facts about tangents and chords. A tangent and a radius will meet at 90 degrees, and the perpendicular bisector of a chord will go through the centre of the circle. Let's have a go at these questions. In this question we're asked to find the equation of the tangent to x minus 4 squared plus y minus 6 squared equals 169 at point 918. We're going to start by finding the centre of the circle, and we just basically do the opposite signs in the bracket. So minus 4 for the x will show it's at 4, and minus 6 on the y will show it's at the y coordinate 6. Now we're going to focus on the radius between the centre of the circle and the point. And we're going to find the gradient of that radius. So we're going to do the change in y, which will be 18 take away 6, over the change in x, which will be 9 take away 4. So it's going to be 12 over 5. Now we know that the angle between the radius and the tangent is 90 degrees, therefore they're perpendicular. So to find the equation of the tangent, the gradient will be the negative sign of the gradient of the radius, which will be minus, and then we flip it. So it's going to be minus 5 over 12. We have a point, because it's given to us in the question, and a gradient for our tangent. So we can use this equation form here, substitute in the 9 and the 18 and the minus 5 over 12, and then expand the brackets, plus the 18 both sides, and we find that we can write our equation as 12y plus 5x equals 261 if we didn't want to have the fractions in it. In this question we're told that a circle C has the equation of x plus 5 squared plus y minus 3 squared equals 10, and the tangent to the circle L has a gradient of 3, and we're asked to find the two possible intersections for the circle and line L. It's really important we sketch this out so we can see what's going on. The first thing we need to do to sketch it is figure out where this is on our graph, and to do that we find the centre of the circle. Looking at our equation, it's going to be at minus 5, 3. So we're looking at the top left quadrant, and we can draw on our two possible lines L, which is one on the left hand side and one on the right hand side. Notice that a tangent and a radii hit at 90 degrees, so if we draw a diameter across, then it will go through both tangents at 90 degrees. And we can start by finding the gradient of this diameter. If the gradient of the tangents is 3, the gradient in the diameter is going to be perpendicular, so it's going to be minus and then flip the 3 to give us minus a third. We can then find the equation of the diameter because we do have the centre of the circle. So we substitute in the centre of the circle and the minus a third, and we find that y equals minus a third x plus 1 1/3. Now I'm going to label on the two intersections we're looking for as A and B, and we need to find the coordinates of A and B. And we're going to do that by substituting the equation of the diameter into the circle equation because we're finding an intersection. So we've got the circle equation, and we're going to substitute in the equation of the diameter the two lines. We're looking for the two intersections. Going to expand the brackets and we get this, and we're going to divide everything by 10. So we've got x squared plus 10x plus 16 equals 0. Factorise it and we get x plus 2 and x plus 8 equals 0. Then we can solve and we find x equals minus 2 and x equals minus 8. To find each of the y coordinates, we can substitute in these x's into our equation of the diameter. And so we're going to substitute in minus 2 and it gives us 2, substitute in minus 8 and it gives us 4. So our two intersections, our point A and point B, are going to be minus 2, 2 and minus 8, 4. This question gives us this diagram, and it asks us to find the equation of line L and the circle shown below. Looking at this, we can start by finding the midpoint between point A and B, because that will definitely be a point on our line L, because the perpendicular bisector of a chord will go through the centre. So to find the midpoint, we add the x and the y coordinates together and divide by 2, and we find the midpoints at 4.5 and 3.5. Next, we can find the gradient of line AB, and we can do that by doing the change in y over the change in x, and the gradient will be -1. Now, the reason we want to find the gradient is because we are looking for line L, and line L is perpendicular to line AB. Therefore, we know that we are going to change the sign and flip it to find the gradient for line L, which will be 1, because 1 over 1 is just 1, but -1 becomes a +1. Then we use our equation form, because we know the midpoint, which will lie on the line, and we know the gradient, we can substitute those in, and we find that y equals x minus 1. Now, we know that the centre of the circle is x coordinate 5, so to find the y coordinate, we can substitute in the 5, and we find that the y coordinate will be 4. So the centre of the circle will be at 5, 4. The length of CA, we can use Pythagoras to find that length, and we find that it's going to be square root 5. The reason we need the length is because that will be the radius, and we need that to find the equation of the circle. To find the equation of the circle, we use the centre of the circle, which we know is at 5, 4, for the first bit, so it will be x minus 5 squared plus y minus 4 squared, and it equals the square of r. The r is root 5, so the square of r will be 5. Let's finish with this. Discuss whether a circle will always have two tangents with equal gradients. If you think you know, let me know in the comments below. And you can come to onmaths.com or click the link in the description to access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.